Well, good morning. This has been one of the hardest travel weeks of my life. I flew southwest yesterday for about 14 hours to get here from Kansas City. So it's good to be here, and my special thanks go to all the folks that have made this symposium possible and invested time and energy in it. I've got to tell you, I'm a radon denier. My background was civil and environmental engineering. In the mid-'80s, I was working at a nuclear weapons plant in Kansas City. We made the real thing. People weren't talking about safe exposure levels. They were talking about total annihilation. So as I saw radon come around, and people talking about that, I talked to my peers and colleagues, other environmental engineers. I was not a scientist. I just went to school to learn about dirt and rocks and water running downhill and moving through pipes. But the engineers around me in the nuclear weapons plant says, radon, says, look, this is a big ado about nothing. I mean, it's a dissipatory waste product. It just decays and goes away. So in the 1980s, as Stanley Watrous was setting off alarm detectors, I was one of the guys on the background listening to my peers, and they were telling me, look, if you want to be scared of something, stay away from those plutonium pits in Department 49. Oops, I wasn't supposed to share. That was classified. What department took care of plutonium pits? And of course, I'm joking. I don't remember the department that did that. But the concern was stay away from the nuclear weapon material. That is your safety concern. Don't spend your time worrying about carbon canisters in your basement testing radon. That's a trivial waste element. Don't worry about it. And I'm sorry I'm getting sidetracked. We've got a limited amount of time, so we can't do it. We can't get sidetracked. But that changed in about 2010 when I left the weapons plant and went to work for a foundation company. Like I say, my background was civil environmental engineering, but I had sort of gotten pigeonholed on the environmental side because that came real big in the 80s with digging up buried tanks, gasoline tanks, and petroleum tanks. So all my bosses says, hey, you've got environmental in your resume. Here, you handle the environmental projects. So I ended up being stuck with all the environmental stuff. I got into the foundation repair contractor, and he called me in and says, hey, we've got customers that are saying that our sump pump systems are pulling radon gas into their basements. You need to study this and give me some recommendations. I studied it. Got test instruments, set the instruments up, went to class. Bruce taught me the real concerns about radon and the inhalation hazards associated with it. And my experience just led me, like I say, I'm sort of a Gomer Pyle engineer. I just came up with the idea that could you take two funnels and stick them together in an opposing fashion so that as air flows through the funnels, enclose those funnels in a chamber and then depressurize the center gap between the funnels. Would that pull radon if you spiral the air through those funnels? Okay, well, Nicole told me I had to embed questions into my presentation, so here is my awkward quiz question. When the radon atom undergoes radioactive decay, it ejects a +2 charged alpha particle composed of 2 protons, 2 neutrons. This explosion releases 5 million electron volts of kinetic energy, propelling this charged particle to the initial velocity of 5% of the speed of light. Converting this to miles per hour, because that's what I deal with every day, how fast is this? Okay? Well, the answer is it's 33.5 million miles per hour. Okay. You'll get that one right on the quiz. Okay. As I went back pondering my decisions of, as I ran radon tests, I would walk in, I would see air conditioners, the furnace setting up, and the filter slot there open on the basement floor. So as that furnace operates, it's pumping radon to the 3rd floor of the building. And I'd say, this is nuts. How are you going to get rid of the radon? Well, they come in, they drill a hole in the basement floor slab and put the extraction fan or pipe in the floor, follow appropriate protocols, and depressurize the subfloor, and that eliminates the problem. What if you're in a muddy area like my neighborhood and the subfloor silts in and compromises the extraction of the radon gas? Well, you're going to end up with fugitive radon coming in the path of least resistance. My fear as a foundation engineer, and of course my job was fixing broken foundations, and where did I find them? Everywhere. Every foundation breaks because the soil moves as moisture moves through it. It expands, it contracts, it shifts, and over time the sealed joints start leaking. Okay, so my concern was saying, okay, would it work? Is there a way to affordably? That's the big question. If it costs you $1 billion, it's a dead idea. But is it feasible? Is it affordable? I've tried building units and installing them in ductwork. As a mechanical engineer that's approaching 70, you can imagine how fast I am with fabricating sheet metal. So I said, hey, I'm going to have to come up with a standalone unit. Don't have time to build them inside everyone's furnaces. So that's in work. But conceptually, I said, hey, if you put some kind of an extraction system in the ductwork, it might work. So I put together a crude plexiglass and cardboard and duct tape chamber and started running a test with a cheap $20 carbon monoxide test instrument, because that was I didn't have the $1,500 for a quality lab quality instrument, and I said, hey, if it's a dumb idea, don't waste your time on it. But when I tested this thing, I found it extracted carbon monoxide out of the atmosphere. As you can see from my simple graph over there, I used a gasoline engine to fill an isolated closet that was my testing chamber. And once I got the level to 800 parts per million, I turned on the extraction machine so that the air in the closet would be circulated through the extraction mechanism. In 5 minutes, it pulled carbon monoxide to 0. Like I say, that's not NASA test instruments, but that's a Walmart CO meter. As a Gomer Pyle engineer, I said, gee whiz, Mr. Sergeant Carter, that looked significant to me. It took me 10 minutes to pump carbon monoxide into the chamber to get it to 800 parts per million. I did turn off the engine, but I says, hey, if I've pulled it down in 5 minutes, that seems significant. But being from Missouri, I'm a doubter. I says, hey, I'm probably tricking myself. It's just the fact that I'm extracting air and I'm tricking myself. But you can see in this slide that this simple funnel system has a fixed, this isn't rotating, it's simply fixed, attached to the funnel. So as air is pulled through this funnel and fan blade, the fan blade forces the air to rotate and spiral into this vortex tube, is what I call this thing. So as I ran that test, I says, what if I remove the fan blade? Well, everything's going to run the same. It's going to pull the same volume of air, which was about 800 CFM that was going through this ductwork. But without the blade, it won't rotate the air. What will the difference be? If I was just sucking the carbon monoxide out the extraction fan, it'd be the same. It might even be a little faster, because without the obstruction of the fan blade, it might lower the carbon monoxide faster. But it actually took, instead of 5 minutes without the fan blade, it took 30 minutes. So it appeared to me that there was something significant about the air rotation through this plastic bucket. I ended up researching this with, I'm sorry I don't have a MIT PhD, but through paying enough lawyers, in-laws, and outlaws, I patented this device, thinking it might be useful. I tried to invest in a little better chamber than my cardboard and plexiglass, and started taking additional measurements, and found that there was even more going on with this funnel and a fan blade. The air friction spiraling into the funnel, this plastic bucket, was actually picking up an electrostatic charge. My estimates, I've burned out a lot of test instruments trying to measure the voltage of how much static electricity was generated by that, but my crude estimates are that it's a couple of thousand volts, which was far more than I expected. But the physicists tell me that when you have a charged particle and you move a charged particle, they tell me that that generates a magnetic field. Okay, that's getting way above my pay grade. But as I took measurements on this thing, I found the air that I was extracting out of the chamber had less oxygen in it. The air that was going through the clean air stream had more oxygen. Not a lot more, but about 4,000 parts per million. And that to me seemed like a good thing. It seemed like a good idea if this actually would enhance the oxygen that was going on. I took this process to 3 different universities, and they all refused to try to test this instrument in a university. One university says, well, for maybe $2 to $5 million, a research project could go through and do testing. But then when I asked him about radon, he says, no, I'm not going to bring radioactive gases into our pristine laboratory. So I couldn't find in my budget a university to take on the project. So I talked to my geologist friends, and one gave me an idea, said use this black shale we've got up here in Kansas City. And I've measured elevated radon around that, so I know where you can get some. So he and I loaded my trunk with black shale. Okay, thank you. And we set up a test chamber. And this slide, I've got to tell you, on the left it's showing ambient radon at about 2.7. Okay, I'm not pushing anything through the black shale yet, but after about 24 hours, to make sure I didn't have anything spooky, I was trying to isolate this test chamber from ambient. I didn't want building contamination to interfere with my test. But when I saw after the first 24 hours that, hey, it looks like we're pretty stable, around 2.7, I turned on the fish tank pump that blew air into the black shale that I had broken into gravel. And it elevated the chamber radon to about 40 picocuries. I've got to tell you, that scared me, guys. I'm not really a radon testing professional, so when I saw this chamber pushing out 40, I was concerned for the guy that was renting me the building, fearing that I might be contaminating this property. But it was isolated inside a chamber. I let it run for a few days to make sure this wasn't just a blip, some kind of a moon gas phenomenon, and then turned on the extraction process and ran it through the vortex. I'm sorry. The right side, the radon gas level was dropped to about 0.2 in about 5 hours. And it was dropped very close to 0.0 over the next 24 hours. Now, like I say, people have not come to me to want to run tests on something like this because it would take major players. Okay. So in the last minute, let's just say the big question I had was, is it even worth messing with low-level radon? If you can get it down below 4, do you have to worry about the bottom 4? My conclusion, looking at the medical research, is yes, it makes a difference. It's a contaminant. And if it's at 4, that means sometimes it's getting higher than 4. It could be 8 or more. But as I looked at that, let me tell you another quiz question that a geologist that gave me the radon bucket idea. He said that he had a lawsuit where microscopic research of artwork was verified to be part of the original collection because they studied alpha tracks on that device. So the answer to this question is yes, radon can be used for beneficial purposes. Thank you for your attention.